All right, I'm back. We're on page 102 of the math analysis notes, and we're getting near the end of these. And we kind of pretty much know what we're doing, right? 14 formulas, see if you can make it match. The issue that we're going to face on these is when I look at the original problem, I see 20 and 21. There's no way that those can be the sine and cosine of any angle. It doesn't matter what. So what I need to do is I need to think. So if I had the ordered pair, 20, well, maybe 2021, it doesn't really matter, or 2120, doesn't make a difference. The r that we're going to use is 29 because the square root of 20 squared plus 21 squared is 29. That's my favorite triple. That's how I know that. And I guess it's kind of up to you to know that. So how are we going to make this happen? So I need to divide by 29. I can't do that to just one side. So what I'll do, I have a choice. I can either just divide everything I see by 29, or I can multiply by a very clever form of 1, which is what I'm going to do to be like a little, I don't know, just a little weird, I guess. So I'm going to multiply by 29 over 29, the original, right? That's the same as just dividing both sides by 29. But for some reason, I want to do it this way. Like, what if there was no y there? You know, what would you do? So here, I'm going to make it 29, just sitting out there. And then 20 over 29 sine of x plus 21 over 29 cosine of x. Okay, so I see a plus in the formula. So I'm thinking two different formulas make a lot of sense. The first one that makes sense to me is sine of a plus b, because sine of a plus b has a plus in the formula. And that would be sine a cosine b plus cosine a sine b. So now what I'm going to do is rearrange what I have so that it fits that. So I'm going to say, also I'm going to move this down a little bit to here. So I'm going to say that I am looking at sine x, because I like the variable to come first, and then 20 over 29 plus cosine x, and then 21 over 29. Okay, so what are we dealing with? We've got the cosine of b is 20 over 29, and the sine of b is 21 over 29. So for angle B in this case, I know the ordered pair is 20 over 29, 21 over 29. So I know that B is the arctan of 21 over 20. So this I can rewrite as the sine of, so it's a plus b. So in this case, it's x plus tan inverse of 21 over 20. But then if I go back up to the original, so I got to take this and go back up here and sub in, I'm going to say that y is equal to 29 and then sine of x plus tan inverse of 21 over 20. Okay, so that is going to be my first answer. And then there's another formula that works. So what's the other formula that has a plus in it? It's definitely going to be cosine of x minus y, or cosine of x minus of a minus b, whatever, however you want to say it. So I'm going to say cosine of a minus b is cosine a, cosine b, and then plus sine a, sine b. So now my job is I need to rearrange this so that it like works. So what I'm going to do is I'm going to rewrite it as cosine x and then 21 over 29. So I'm leading with this, and because of the plus, it doesn't matter. I can just easily do that. So I'm doing that, and then plus the sine of x and 20 over 29. So for this, angle B as the ordered pair, so cosine of B is 21 over 29, and the sine of B is 20 over 29. So we're going to do the ordered pair 20 over 21 over 29, 20 over 29. And so B, well, B is equal to the tan inverse of 20 over 21. So we could also say that y is equal to, you need to keep the 29 that's there, and then cosine of x plus tan inverse of 20 over 21. So if you do enough of these, you can almost just do them in your head, which, you know, it takes a little bit of practice, like maybe a lot of practice. Maybe you never get there. You know, that's also okay because you can always just show the work. But look what happened here. Like sine, cosine, definitely x, definitely plus, but the angle switched. It went from arctan of 21 over 20 to arctan of 20 over 21, flipped. You will find that happens like every time. Let's try another one. So here, I'm going to immediately just say that y is equal to 5, and then 4/5 cosine plus 3/5 sine. All right, so it's plus again. So we're thinking like the same basic idea. So I know that I can rewrite this as 5, and then I'm going to do cosine x times 4/5 plus sine x times 3/5. So I'm thinking of this as cosine, cosine, sine, sine. That's what I'm thinking. So let me just write that in. This cosine x, cosine y, plus sine x, and sine of y. That's what I'm looking at this as. So I know that y uses the ordered pair 4/5, 3/5. So y must be equal to the inverse tangent of 3/4. So we can say y equals 5 cosine. So cosine, cosine plus sine, sine is cosine of x minus y. X minus tan inverse of 3/4. And we can rearrange it again. So this is what I mean by like when you know what you do, when you know what you're doing, you show a little bit less work. So here I'm going to rearrange it as sine of x times 3/5 plus cosine of x times 4/5. So now I'm kind of looking at it as sine, cosine, cosine, sine. So sine, cosine, plus cosine, and sine. So I know that for angle y, the ordered pair is 3/5, 4/5. So the angle y would be the inverse tangent of 4/3. So again, it's like we flip the function from sine to cosine, cosine to sine, and we take the reciprocal of the argument of the angle, I guess maybe is the easiest way to say that. So this is going to be y equals 5, the sine of x plus y. So x plus tan inverse of 4/3, and we get that. So these, when we get to the calculator, these should be equivalent, and not only should they be equivalent to each other, they should be equivalent to the given expression. So I will type those in, and we'll see if that worked out. Let's try one more. So I don't know if this is running long. I hope not, but you know, you just never know. So 12 and 5, not going to work, but it is a Pythagorean triple. So 5, 12, 13. I'm going to divide everything I see by 13, but really what I'm going to do is this, y equals 13, and then the quantity, well, I'm just going to write 12. Okay. 12 over 13 cosine x minus 5 over 13 sine of x, just to like get the ball rolling. All right, so we're good there. Now, how do I want to look at this? I'm going to look at this. There's actually like two ways you can look at this. So I could say that I'm going to rewrite it rather than say anything. So I'm going to do cosine x and then 12/13 minus sine x, and then 5/13. So I'm thinking cosine, cosine, sine, sine here. Let's do that. Cosine, cosine, sine, sine. So that's cosine of x plus y. But in this case, for y, the ordered pair would be 12/13 and 5/13. So y would be the tan inverse of 5/12. So we would end up with y equals 13 cosine of x plus y. So x plus tan inverse of 5/12. Okay, that's one option. Now the next option, I'm going to do it in kind of a weird way because I just like don't want to deal with it. So I'm going to rewrite this as, I guess I'm actually, what am I going to do? I'm going to keep it the same. No, I don't know what I'm going to do. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. I'm going to factor out a negative. I'm going to say that this could also be equivalent to the negative of 13. And then you would have 5/13 sine minus. So the choice that I made is when to deal with the negative, basically. And I feel like dealing with it right away is the easiest thing. Just factor it out. And now it looks like sine cosine minus cosine sine to me. It looks like sine of x minus y. So I'm going to go with that. There are multiple ways to do this particular problem. I'm thinking right now that what I have is sine cosine minus cosine sine, which means that, I guess I should put this in parentheses. For the angle y on this one, cosine is going to be this part. So it's 5/13, and then sine is going to be this 12/13. So then y is the inverse tangent of. So what we're trying to do is make sure that the angle always comes from the first quadrant. That's basically what we do when we make our choice of a formula. And so here, I'm saying y is equal to negative 13, and then it's sine cosine minus cosine sine, so sine of x minus y, which is tan inverse of 12/13. These problems are like sort of challenging. So like don't feel bad if you're thinking I'm going to need to practice these a bunch more, because you probably do. On the plus side, you can make up all the problems you want. Pythagorean triples are definitely your friend when you're picking coefficients, but like do whatever you want to do. So I'm going to check these. How am I going to check these? I think we found that T expand just works on, no, Trig expand. I think Trig expand will work on these. So I'm going to add a problem, a calculator page, and here we go. So I'm going to do T expand. This is where like, this video is pretty long, so if these don't work, I don't know. This is the given thing, and then T expand 29 cosine of x plus arctan of 20/21, which is definitely not the same. What the heck? What did I mess up? Plus 29 plus 20/21. 21, and then that minus. Why is that? What is happening? No. Cosine, cosine, minus. Oh, it's supposed to be minus. What the heck? Okay, so I got to change that in the notes. All the work all the way through suggested that, and then I just flipped it at the last second. I do that a lot, it turns out. That might be like one of my, okay, so I'm gonna go back into the notes and fix that at the end, hopefully if I remember. Let's keep going. Trig expand. Let's hope I didn't do that again. Cosine x minus arctan of 3/4. Trig expand. 5 sine of x plus. Man, you had to watch a long time before I figured out that was wrong. That's all right though, I guess. I tell myself. X minus arc. I know I forgot the Trig expand here. T expand answer. Was I supposed to get that? Oh wait, am I doing the same problem again? I am. What a silly person. These are the ones I need to check. Here we go. So t expand 13 cosine of x plus arctan of 5 over 12. T expand negative 13 sine of x minus arctan of 12 over 13. That doesn't make any sense. 12 over 5. Got to fix that one too. But we get the same thing. All right, so I'm going to go back to the notes and fix the two things that I need to fix. Both of which are just like weird mistakes. But you know, I don't know, 100-something pages in, it's all right to make some mistakes. Sort of. I mean, it's not really great for your education that I'm making these mistakes, but gone. So this is supposed to be a minus as indicated in the actual problem that we did. So that would be minus, and then I will highlight that in red to indicate the error of our ways. And then the other one that we had to change was down here. This one's just silly, man. 12 fifths. So this has to be 12 fifths, and then we'll highlight that in red also to highlight the error of our ways. And there you go. All right, so probably a long page. Do more of these. Find more, write your own. Just do like sine, cosine, pick a Pythagorean triple, divide by the hypotenuse, or don't, and then do it in the middle of the problem, whatever you want to do. Practice makes you a lot better at these, but I've done thousands of them and I just got 2 of them wrong. So make sure you're trying a lot of problems, and I'll see you in the next video.